Welcome to my channel. I'm Zhang Jingxu. Let's look at the problem 55 in chapter 21. Chapter 21 is about electric charge and electric fields. So we look at this picture 21/28. They look like this one, right? Tell you suppose the charge Q is only distributed uniformly on the top part, on the upper half. So we draw it just half of this ring, and no charge on the lower half. So it looks like this one. And then we need to determine the electric field at the P. So for this one, we can see the wire's radius is A, right? So we consider a small fraction on this wire. The length of this arc can be written as A times d phi. Agree? Yes. And the next part, can you write down the charge for this small fraction, dq? Yes. It is the charge density, lambda, times the arc length, A times d phi, right? And this charge density, lambda, we can use the total charge Q divided by the length for the whole half ring. The half ring is pi times A, right? Then it can be simplified as this term. The next one, we can see the distance from the small fraction to this position P. We call it R. And R squared equal to X squared plus A squared. We can get it in this triangle, right? Now we can see for this small fraction, charge. So this part, the electric fields will radically outward follow this direction with magnitude dE. Do you agree? Yes. Now we write down the magnitude for dE as 1/4 pi epsilon naught and dq divided by r squared. And then input the dq and r squared there. We get the answer, look like this one. The next part, you can see this is dE is a vector. We can project in x component and y component. Do you agree? Yes. So we use dE cosine theta, project on the x component, and the y direction we have dE sine theta. This is the magnitude, right? Yes. So next step, we need to write down sine theta and cosine theta. So this is also angle theta, right? And so we can write the cosine theta as x/r. So we write it there. Sine theta as a/r, right? Now we input the dE cosine theta in this dEx, and then simplify it look like this term. And input dE sine theta in this function, and then we find dE equals to this term. The next part, we need to do the integral for this phi, right? We can see the phi is from the 0 to the pi, agree? So do the integral from 0 to the pi, you get the answer for magnitude ES. And do integral from 0 to the pi for the dEy, you get the EY. We write the answer there. Thank you.